Okay, I'll continue. So we're just installing CYPELEC Networks. And so when you get to the end of the installer, it's very important that you keep this box checked, because this will install the BIM Service Center Synchronizer. And this is a very important tool because it's used for, it's the communication tool used between the BIM server and the local computer that you're using. So I already have it installed, so I'm going to cancel out of that. But close. This is the tool here. I have it open. And so this is the communication tool between the BIM server and the local computer that you're using. And without this synchronizer open and running, you won't be able to export any work or import any of the files from the BIM Service Center. So it's important that you have it installed and running. And you can see here that it has loaded the new project that I created, and the tick suggests that everything is up to date. So with everything up to date and the installer finished, we can go ahead and open CYPELEC Networks. Just log into my account. Okay, so the interface here is split into 4 sections. From the file section, you can create new files, you can open existing files, you have access to some example files which have been pre-configured, you have access to the recently opened files. The help section has program documentation and some licensing information, and then you also have your status of your connection status to the BIM Service Center. So to begin, I'm going to open one of the example files. I'm just going to change the background color so it's a little bit easier to see. Okay, so the interface is divided into 4 sections. You have the workspace window here, which can be navigated using the mouse wheel to zoom in and zoom out. You can pan by holding the wheel down, and you can select elements in the window with a left click. And next to that, on the left, you have the project tree, which will contain all of the diagrams associated to this file, and you can navigate through those with a left click. You can also click edit, and you can change the reference and some of the settings for the paper size. Set. Below that, you have the status load case menu. From here, you can create different load cases used to compare different loads for your design. So for example, I can create another load, and you can alter the use factor. It's a useful tool for making quick comparisons for different settings for your design. Okay. And then the last section at the top is the primary element toolbar. So from here, you have a large selection of settings to configure. You have elements to place, editing tools, and analysis tools. Okay, so from this simple graphical interface, users can easily create and edit power diagrams and simple line diagrams. It incorporates a large variety of electrical equipment to create diagrams such as, for example, power supplies, generators, 2 and 3 winding transformers, low and medium voltage cables, high voltage transmission lines, capacitor banks, electrical loads and motors, as well as protection devices and other electrical switchgear. CYPELEC Networks analyzes the load flow and calculates the voltages and phase shifts in buses, the currents in lines and branches, and the active and reactive power flows of the electrical system. So to begin, I'll start in the top left corner with general settings. So the general settings has 2 sections. In the libraries is where you load your elements into the library for use with the program. So for example, we have the following cables loaded in. You can also manually add your own cable families or the cable families of manufacturers that you use. And so from here, you can designate a reference and all the relevant properties for your cable family. And opening up cables is where you can input all of the different cable sizes that you want to use with all the relevant variables. And you have a legend at the bottom explaining each of the variables that you will input. So I'll cancel that. And cancel that. Below the libraries, you have configuration. So the first option is design options, which allows you to configure the frequency of the network and the base power. Using the help icon next to the frequency of the network will give you a brief description of the variable. So you'll see this a lot in the program, and it's very useful just to offer an explanation for the variable that it is attached to. Next, we have the line checks tool. And so from here, you have control over the checks the program will use to verify the validity of the design. For example, you can activate a maximum voltage drop accepted, or a maximum error between the nominal voltage and the operating voltage, or a maximum short circuit current. Next is the units tools. And so this is used to alter the individual units associated with different elements and different properties. You also, so it's pretty simple to change the units. You just simply click and it will open a drop-down menu. You can adjust the decimal digits as well. And you also have the option in the top right corner to import a predefined unit system, which will apply universally. Next, we have the drawing options. And so from the drawing options tool, you can edit the information displayed in the drawing. For example, I can unselect all of the drawings associated with the two-winding transformer, which is the element you can see here. If I unselect those, accept, you can see all the information that was displayed on the drawing has disappeared. So it is a useful tool for configuring the design of your drawing. I can bring those back in. And you also have options for altering the text size and the table views. And so you can do that for any of the elements that you place into the window. Okay, I'll accept. The next section is for supply sources. So we have 6 supply sources. The primary is just a generic supply. So from here, you can designate a reference. You have the properties section for nominal voltage, the efficiency, the connection, and the connection diagram can all be configured. And then at the bottom, you have the short circuit properties. For any additional information, you have the consult results button at the bottom of the window, which will basically give you an explanation of where the data has come from for this prompt. We can accept that and accept. The next tool is for the two-winding transformer. It's a similar tool. However, it has a few key differences, such as the introduction or the inclusion of the secondary voltage. You have a secondary connection. You have the inclusion of the impedance, which will be determined by the manufacturer of the transformer. However, you can also use the blue arrow to determine the typical values given the properties that you have selected. So there's also the functionality to designate a tap. It can be a fixed tap or a tap charger. And at the bottom, there is the load data. The load data will take information from the input connection. For example, when I open this two-winding transformer, the load data here will match the input results shown on the diagram. And this is because this lock symbol here is open. If I wanted to, I could overwrite all of this data with my own values and then lock them in by activating this tool. The load data would then pass through the transformer and continue on through the following sections of the diagram. Okay, next we'll open the generators tool. And from here we have a similar prompt. We can adjust the properties of the generator, including the apparent power, the active power, power factor, and reactive power, the connection configuration, the operating conditions, which can be set as a fixed voltage with reactive power limits, fixed power with voltage limits, or as a supply. But below that, we also have the short circuit data. We also have the option for the 3-winding transformer. The window is very similar to the 2-winding transformer. And the last two options are for a battery and a photovoltaic generator. Both of these are just graphical representations, and so there are no variables to alter, and they don't, so they're not taken into account for the load flow or short circuit analysis. They're just for the graphical representation in your diagram. We also have those in terminal elements such as ground, lamp, and contactor in protection, high voltage circuit breaker. So I'll just get those out of the way now. And we also have measure and control tools, which are also just graphical representations which you can add into your diagram. Okay, moving on to conductors, we have 3 options for conductors. You have cables for low to medium voltage, short range transmission. You have your transmission lines for high voltage, long range transmission. And then we also have the manual introduction of impedances. So starting with cables. So from this window, you start in the top left corner and you designate the voltage level and the length. In connection, you can designate the nominal voltage and whether or not your connection will include a neutral conductor or a protection, for example. And below that, in the family section, you can designate the number of conductors per phase, the configuration of the conductor, the number of cables, and using the select family option is where you designate the family of the cable. And lastly, you need to designate the cross-sectional area of the cable that you're using. Below that, you can see in configuration that I have an error stating that the number of available conductors is less than the number that is required. And so, as you can see, I've selected to include a protection. So I need to include my protection cable, and now my selection is correct. Moving on, we have the installation section, which allows you to designate the type of installation, which will impact the impedance of the cable. You also have sections. You also have variables for the ambient environment surrounding the cable, such as the temperature and the number of additional current carrying conductors in the raceway. So the impedance section displays the current impedance of the cable, and below that, again, you have a section for load data, which can be overwritten using the lock symbol. For further information, you can use the consult results button. The transmission lines is very similar to the cables prompt. The first thing you'll notice is that I'm getting an error saying my library is empty. So if I go to the general settings, enter the transmission lines library, I can import a family of conductors. I'm going to import a transmission line configuration as well. And I'm going to import an earthing cable. So now when we go back to the transmission lines prompt, it is allowing me to select a family of cable. So the main difference between the transmission line and the regular cable is in the installation section. I have the option to choose between triangular separation between the phases, or to choose to elect to use the transmission tower. And so now I can select the transmission tower from the library that I loaded. There we have it. And I just need to include the earthing cable for this configuration of transmission tower. So I select ground and I select the earthing cable that I just loaded. Selection is correct, and I could input my transmission tower into the diagram. For the impedance tool, it's very simple. You have your generic properties for impedance and your settings for impedance here. You also have 3 options for the graphical representation. Next, you have the terminal elements, where you have the motor, the load, capacitor bank, the capacitor, and the imported load. So starting with the motor, it contains all the relevant variables for AC motors, starting with the power and nominal voltage, the number of phases, the operating conditions, allowing the configuration of 3 different regimes, the angular velocity calculation with the number of poles, slip, and actual angular velocity. The further operating conditions includes the use factor, the starting time, the inrush and peak current, with the right side of the prompt displaying a graphical representation of the motor operation. The load prompt allows you to input whatever sort of load you'd like. It's very simple to use. You have your connection where you designate if it's a single phase or 3 phases. In data, you designate the nominal voltage of the load, as well as the load data, such as the apparent power, active power, reactive power, power factor, or the current. And then at the bottom, you have, in the operating conditions, you have a use factor, which you can designate as well. Next, we have the capacitor bank tool, which has all the properties for a capacitor bank and the load data. It also has a useful wizard, which will automatically configure the number of blocks in your capacitor bank to best reach your desired power factor. The capacitor, very similar, except instead of using the number of blocks, it is just a single block capacitor, so you don't need to use the wizard. And lastly, you have the imported loads tool, which is used for connecting to projects that have been completed with another one of the CYPELEC suite software called CYPELEC Core. The next section is for protection. The protection elements include fuse, contact, low voltage, circuit breaker, and transfer. Starting with the fuse tool, I'll actually start with the low voltage circuit breaker. And from here you can see that the library is empty, so I will go into my libraries and load a circuit breaker. The low voltage circuit breaker and the fuse prompts are very similar. However, the circuit breaker prompt is a little bit more complicated, so I'm going to choose to explain this prompt instead. So from here you can designate your reference, the service of the circuit breaker, and below that you have a number of tools for filtering through the library that you've loaded in, such as whether or not you'd like your circuit breaker to be solid state, thermomagnetic, or electromechanical. You can filter by manufacturer, type, standard, the maximum insulation voltage, number of poles, or the size. Below that you can filter by the model, and then finally by the individual product that matches the settings you've filtered. And in the bottom right corner, you have the all of the properties of the product that you've selected to import. And in the top right, you have the properties graphically represented. Okay. The other two tools, both contact and transfer, are just a basic switch tool. So the properties are simple. You can either select between open and closed for the contact, or for the transfer between the A or B service. And so the line tool, I'll just explain quickly, allows you to create a series of elements, just like so. I can create a cable and a load, and it allows you to save this series and input it as a single piece, just for faster design of your installation. The next section is the connections. From here, you have three very useful tools. Your connection tool is used to connect, oh, sorry, one second. Sorry about that. I'm just going to reload the program there. Okay, so the connection tool is used to connect different nodes of the diagram, like so. You just left click, and I can left click anywhere in the diagram and continue my connection. Click again. The continuation point tool is demonstrated here in this example, and so it is used to connect the installation between different diagrams. So it's very useful for creating large-scale electrical installations. For example, I can separate my supply side with the load side of my installation. So it's more, I can visually display the installation in a clearer way. So as you can see here, I have a continuation point with a reference G1. And so this is the continuation of the G1 continuation point here. And so when I run the analysis, the software will assume that it is one connected installation. The next tool is the buses, which allows you to install buses into the installation. I have a number of useful tools for improving for inputting text into my diagram, such as the identifier and the text box tool. Very simple to use and useful for when you want to finalize your results and print your diagram. It's very useful for creating tables and legends for your diagram. And so the next tools we have are the editing tools. We have, for example, editing allows you to open up all the properties of the different elements in the diagram. You have different moves tools, such as moving a group of elements or moving by a single node. Or we have the move a group of elements tool, allows you to select a group of elements and select a node to move around as a reference point. Another tool we have is the copy tool, which allows you to simply make a direct copy of something else in the diagram, like so. We have the delete tool, which allows you to highlight a group of elements, the left click, and then right click to delete. We have the rotation tools, which allow you to rotate single elements around a node or to rotate a group of elements around a given reference point. We have the match tool, which allows you to match the different properties of elements of the same type. For example, if I have my transformer at 10,000 kilovolt amps instead of 5,000, like so, you can see this is 10,000 and this is 5,000. Now I can select my 2-winding transformer, and all the other 2-winding transformers will be highlighted, and I can select the ones that I would like to match, right click, and they will match. I have a tool for changing the service of switches and transfers. I have a tool here, copy to another diagram, which is useful for copying elements or groups of elements from one diagram to another, just like so. There you go. Okay, so the next tools that I'm going to explain are going to be the analysis tools. But to do so, I'm going to create a basic diagram from scratch. So I'm going to create a new file called demonstration. I'm going to associate this with the project that I created at the start, demonstration, and accept. Okay, so to start the project, I need to import my libraries. So I'm going to go into the cable library, and I'm going to import this cable here at the top. I'm going to import some transmission lines as well. And I'm going to import a circuit breaker. So to begin, I will introduce a supply. However, I'm going to get this prompt here, which is basically telling me that I need to define a diagram before I can introduce elements, and it's asking me if it would like me to create a circuit diagram with the default values. So I'll select yes, and you can see it's created an A3 circuit diagram for me. Okay, so for my supply, I will create a 10,000 volt supply. And all of the following properties are acceptable. So I click accept, and I can place my supply. I'm just going to turn on the snap to grid tool up there. Okay, so I accept, and I place into the diagram with the left click and right click to exit the command. The next thing I'd like to introduce is a transmission line. So I'm going to introduce a 20-kilometer transmission line. I have to make sure that it is at 10,000 volts. Select the family that I loaded into my library, and I can click accept. I'm going to draw a bus below my transmission line. The left click, drag, and left click again, and then right click to exit the command. Now I will use a 2-winding transformer. So I will put my power at 630. My primary voltage is at 10,000 volts, and my secondary voltage will be at 380 volts. The rest of the properties are acceptable, so I can place my transformer into the window with a left click. And now that I have reduced the voltage, I will use a cable. And I'm going to make this 40 meters with my nominal voltage now at 380 volts. Select the family, and it loads my library. and I can accept. And now I'm going to create another bus, and this will be the bus that I attach the loads to, so I'll make that a bit longer. And I'm going to use another cable. I'm going to increase my cross-sectional area for this cable and place it right here. And below that, I'm going to attach a load of 380 volts. Okay, so the next important step, I'm just going to save. The next important step is to use the connection point tool to connect all of these elements together. Sorry, we're just having a bit of trouble running this version of the program with this version of Windows, so I'm just going to change that in the properties so that doesn't happen again. So I run it in Windows. It's a bug we've recently recognized, so we're just working on fixing that in the next update of this software. So I'll reopen my demonstration file. Okay. So I'll connect the different elements with the left click, just like so. Left click, left click. Okay, so now everything's connected and we can run the analysis. So I'll run the load flow analysis, and it's saying that I first need to define a load case. And I can start with the default values. So I'll say yes. And as you can see, the load flow analysis has been completed and there are no errors. So my installation has been installed correctly. And so now that it has passed, I would like to introduce some more loads. And so to do so, I will move my elements down so that I can fit a circuit breaker, and I'm also going to use the copy tool to copy the load across so that I have 3. Okay, so I'm going to connect these to my installation using the connection tool, and I'm going to install a circuit breaker. Okay, so for my circuit breaker, I know that it needs to be somewhere between 131 amps and the, let's run the analysis again so I know. Okay. Okay, so I'm going to install the following circuit breaker into my diagram. And now when we run the analysis, well, we can see that there have been no errors found. Just to explain the load flow analysis tools, there are a number of other options. We have the load case analysis tool here, which is used to display the results of the load flow analysis in easy to read form You can also use it to compare between different load cases that you create as an easy comparison tool. In the top right corner of each of the tabs for the results, you can generate a printer-friendly version of the results. So we have the results for buses, cables, loads, supplies, and protection. Next to that, we have tools for adjusting the settings for the results, whether you want that in power units or as the default value. You can adjust the settings for voltage, current, or power. The next tool is the design results tool, which will generate a printer-friendly version of the current load case analysis results. And it generates the results for each of the available nodes. Below that, you have the settings, which allows you to adjust the settings of the analysis, such as the number of iterations and the maximum allowable error. You also have a help tool to further explain those variables. Below that, you can adjust a global load diversity factor, and you can select which of the load cases you would like to analyze. The checks tool allows you to display all of the errors that have been found. However, there are no errors, so everything has been verified. And you have a show hide results tool for displaying the results on the diagram. The next tool for analysis is for short circuit analysis. So if we try to run the short circuit analysis, we get a prompt saying that we need to select a bus to run the short circuit analysis on. If we open up the settings, we can select which elements we'd like to analyze. So I'll analyze at both bus 1 and bus 2 and run the analysis. And so you can see here are the results for our short circuit analysis. There have been no errors, so that's okay. And again, you have very similar tools, such as the load case analysis tools for displaying the results in tables, with printer-friendly reports being able to be generated. You have options for displaying the different types of short circuit results, whether that be three-phase, two-phase earth connection, single-phase earth connection, or all of the different types. And you have settings for adjusting the phase and whether it is the maximum or the minimum results. Adjacent to that, you have, again, the design results, which will generate all of the results taken at each of the reference points and for each of the different types. In the settings, you can adjust the voltage factor for short circuit currents, the fault impedance, the breaking capacity in circuit breakers, and again, you can adjust which of the load cases you would like to analyze. You have another of the checks tools, and again, you can turn on or off the results for the short circuit analysis. So once you're satisfied with your design and you've run your analysis successfully, you have a number of options for displaying or exporting your results. If you access the file menu, you can generate a number of reports, such as the information for the cables used in the design, the information for the transmission lines, and you also have the drawing tools to export your circuit diagram. Just like so, and you can export either the load flow or the short circuit diagram. By clicking this detailable drawings button, you can see your diagram in detail, and you can export or print like so. Okay, so that is the basic functionality of the CYPELEC Networks software. If you have any questions, please let me know now. Otherwise, we've recorded the webinar, so if you'd like to go over it, you can leave your email and I can send the recording to you.